Hello everyone, good evening. So welcome to I think this is our first mass in a YouTube video. So we're going to be treating the following topics. Let me just uh, bring it up. So we're going to treat conversion of different number bases from base 10 to base 2. We're going to treat conversion across other bases. We're going to treat addition of bases, we're going to treat subtraction of bases, multiplication and division of bases all in this video. So make sure to not get lost along the way. So let's jump straight into conversion of different number bases from base 10 to base 2. And let me actively solve this question, this example rather. So we're asked to convert 13 base 10 to base 2. So, okay, so this should work. Yeah. So let me just, okay, so this is how we're going to solve it. I will not really go through all of these instructions because the video will be much better than just me going back and forth, back and forth. So let's get into it. So the first step is to identify what we're what the question is actually asking us to do. So we're asked to convert 13 base 10. So 2, let me change that. Base 2. So we don't know what 13 base 10 will be equivalent in base 2. So just going to say x. Now, how can we actually do this? It's actually pretty simple. So we're just going to draw a line and we'll draw another one here like that. Okay. So we're going to put the 13 here. So let me change the color. 13 here. And we'll put our 2 here. So this 13 is basically just representing the 13 here. And this 2 is the base we were asked to convert it to. So assuming we're asked to convert it to base 3, this would no longer be base 2, but it would instead be base 3. But we're asked to convert it to base 2, so that's what we're going to do. Okay, so let me draw another line just to represent the remainder or remainders, which will be on this other side here. Okay, so let's start. So 2 in 13 is going to be 6. So we're going to have 13 divided by 2 will give you 6. But there's going to be a remainder because 2 times 6 is actually 12, in case you don't remember. And 12 is lesser than 13, so to get the remainder, we simply do 13 minus 12. This is basically like nursery school maths, so I don't think I need to explain this much. So our remainder is 1, so we're just going to write it here. And I will actually write R next to it to represent remainder. Yeah, so remainder 1. Yeah, so the next step is to bring the 2 down again. We're going to have another 2, and 2 in 6 is going to be 3. Now this time around it's not going to have a remainder because 2 times 3 will give you 6 straight away. So we don't have any remainder, so our remainder is just going to be 0. So R 0. There we go. Now we bring down the 2 again because we're not completely done here, we still have 3 here, so we need to keep dividing until this becomes 0. So 2 in 3 is going to be 1, but it's going to have a remainder. Why? 2 times 1 is going to give you 2, and we're supposed to get 3, but since it doesn't exist, we're just going to do 3 minus 2 equals 1. So our remainder is going to be 1, r, and then 1. Now we still have 1 here. Remember I said we're bringing this down to 0, but 2 can't go in 1. So what do? We simply say, since 2 can't divide 1, we're just going to put 0 here and say what's left? 1. And why is that? It's pretty simple. Since 2 cannot divide 1, or rather 1 cannot be divided by 2, because that will give you nothing. So since it will give you nothing, you just simply write 0 here, and you're just going to be like, oh, 2 times 0 will give you, 2 times 0 will give you, sorry for my handwriting, so 2 times 0 will give you 0. So if you follow the pattern we did here, whenever I wanted to get the remainder, what we're simply going to do is just say 1 minus 0 equals 1. So that's how we have this to be our remainder. Okay, so now the next step is to, let me first erase all these calculations we did here. So where's my eraser? Here we go. So let's clean up, clean everything up. There we go. Now we're going to draw an arrow upwards. Let me use a different color like this. Yes. So what this arrow simply means or represents or is trying to show us is that we're going to read from bottom to top. So it's not going to be 1 0 1 1. No, we're going to do 1 1 0 1 because it's the remainders that we'll use to get the value of 13 base 10 in base 2. So we're going to write it out from bottom to top. So that will be 1 1 0 1 base 2. So this is our final answer, and this is what our x should be. Okay, so we've treated converting of base 10 to base 2. Let's take a look at our work again. Okay, now we're going to treat conversion of base 2 to base 10. So we're given this example, so let's treat it. Okay, let's use another page. Okay, so we're asked to convert 110101 base 2 to base 10, and it's actually pretty simple, so just bear with me as I write this out. Okay, so Victor, make sure you fold those mommy's clothes. Oh. Don't just dump it on her bed. Okay, so we're going to write the indexes of each of these numbers. You know how we have like this is our unit, this is our hundreds, thousands, sorry, hundreds, thousands, 10,000, 100,000. Yeah. So it's kind of similar, but instead we're going to use what I like to call the position, but or the index. But we're not going to start from one. We're not going to say this is 1, 2, 3, 4, 5, 6. No, we're going to start from zero, and it's going to be from the back. So pay close attention. So basically, we're going to have the index of this one is going to be. Okay, let me actually just draw a line above it somewhere. So this is going to be 0. Remember, we're counting from the back, and we're not starting from 1, we're starting from 0. So 0, 1, 2, 3, 4, and 5. So these are the indexes we're going to work with. And now, when we want to convert base 2 to base 10, we need to have these indexes above the base 2 number, and then we need to follow this next step that I'm about to show you right now. So basically, we're going to take, let me use this. So we're going to have 1 times 2 to the power of 0. So basically, the format is actually something like the base number, or let me see, the number multiplied by the base, which in this case is what? 2. Then the base is going to be raised to the power of the numbers index. So let me just put this somewhere. Let me see if I can shrink it a bit. It seems like I can't shrink it. Okay, I can. Yes. So just going to maybe put it here. Okay. So just so you can have this as a reminder of sorts. Okay. So now we follow this format that I said now. So we're going to have the first base number, which is this 1. We'll say 1 multiplied by its base number, which is what? 2. 2 raised to the power of 0, right? That's what you would have expected us to do from the since we counted from the back. But whenever you are doing your calculations or solving, we're not going to start from the back, we're going to start from the first number. So let me just take this back a bit. So our 1 is this 1, multiplied by the base number, which is this 2, raised to the power of this index, which is what? 5. So we're going to have 1 times 2 to the power of 5. Now we're going to close this bracket. Let's put it in brackets. Then we're going to say plus. All right. Now what's the next one? 1. This 1 over here. 1 multiplied by the base 2 to the power of what? 4. And then we close this bracket and then move on again to the next number. So if I were to do that, this video will be unnecessarily long. So let's just take a look at what was done in the document. So 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Okay? So that would give you 1 times 32. The 32 is 2 to the power of 5. That would give you 32. And that was how the rest of those numbers with a power were solved. And then when we add everything all together, we'll get 53. So that 53 is in base 10. So I included some questions in case you guys want to solve it. I also did include some questions here as well. Yeah, so you can look into it. Then, all right, now we're moving to the next topic, which is conversion across bases, right? Going to convert from base 2 to base 3, not just base 2 to base 10 or base 10 to base 2. So, this is the next example we're going to treat. And then from there, we'll move on to addition of bases, subtraction, multiplication, division. Yes. So, all right. So we're going to follow these two steps that I have outlined here for the conversion across other bases. Like I said, it's not just base 2 to base 10 or base 10 to base 2 that you can do. You can convert it from like base 2 to base 3 or base 3 to base 2. But you have to follow two steps and we've treated them already. So the first step is to convert from the original base. In this case, I was using this example to just explain. So in this case, the question is in base 2. So in this case, the number is in base 2, right? Then the that's the original base, which is in base 2. Then we convert it to base 10. Assuming the base maybe was maybe base 3, for example, and then said we should convert it to base 4. Our original base would have been base 3 here, converted to base 10. Then in step 2, we convert the resulting base 10 value, that is whatever we get here, we convert it back to base 3. But assuming this was base 4, we say convert it to base 4. So without further ado, let's get into it so we can, understand. All right, so here's our question. Convert 110101 base 2 to base 3. So in case you've already forgotten, we have actually converted it to base 10 because the step 1 and step 2 was basically something like this. So the first step was convert this to base 10. Forgive my letters, to base 10. That's what the first step is all about. This is the first step. Step 1. Right? Now the next step, which is step 2, asks us to convert from this base, whatever we got in our base 10. Let me just put like x base 10. So whatever we get here, we then convert it to what were we asked to convert it to? Base 3, right? Fine. So we then convert it to base 3. You're just gonna have to forgive my handwriting. There we go. So this is basically the steps. First step, convert 110101 base 2 to base 10. Then from then convert it to base 3. Simple as ABC, right? Let's see. So let me just clear up the page. All right. So we've already done step 1 in this last stuff we treated. But let me just bring it out again. Actually, I'm just going to use this. So remember, we first write out the indexes on each of the numbers. Then we say 1 times 2 to the power 5 plus 1 times 2 to the power 4. Then the next one is what? 0. So 0 times 3. Sorry. 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. So our final answer was actually given to be, let me just get that, 53 base 10. So 53 base 10. So step 1 is already done. Convert. There we go. Then our second step is to get that value. Our value was 53 base 10. Now, the next step is to convert 53 base 10 to base 3, which is actually what we did here. We converted something from base 10 to base 2. So in this case, we're converting something from base 10 to base 3. Very simple. So just going to draw a couple of lines, line 1, line 2, maybe a green line for the remainder. Yeah, that's it. So let's look at it together. So 3 in 53 is going to give you 17. And then we have something like 3 times 17 is going to give us 51. So our remainder is 2. So our next 3 again. 3 in 17 is going to be 5. Remainder 2 again. 3 in 5 is going to be 1. Remainder 2 again. And then 3 once again in 1 is going to be 0. Then we'll have 1 here. Now we read from top to bottom. We're going to have 1, 2, 2, 2, base 3. So that is to say that 110101 base 2 is equivalent to this in base 3. I hope this was clear. Okay. Now, we're done with all the converting jargon and all of that. So we're going to be moving on to addition of bases. Now we have 2 methods, so I'll first start with the first method. And I'm actually going to use this document to explain it. Let me get my 2. Okay. So we're going to add 10011 base 2 plus 1110 base 2. So the first step is obviously to what? Align them or line them up appropriately so that it won't be like maybe you put your 1 here instead of putting it here, or you started writing the numbers from here. So that's basically what the lining up means. Okay, now let's follow the documents. Now, we're going to learn these rules here, okay? Base 2 digits can only have 0 and 1. So if you see something, let me do a little scribble. Let's say something like 1, 0, 2, 3, base 2. This is wrong. This cannot exist. Base 2 can only have 0 and 1 in its numbers. It cannot have 1, 0, 2, 3. It cannot have 2, 3. You can have 1 and 0, but it cannot have 2 or 3. So this is wrong. Let me clean that off. Okay. So base 3 can have 0, 1, 2. So that means if you see something like 3, 5, sorry, let me write this here. 3, 5, 6, 1, base 3. This is wrong because base 3 digits can only have 0, 1, and 2. So if you see 3 or 5 or 6 or anything higher than 2, it's not a base 3 digit, and this is clearly a mistake or something to confuse you. Okay. So this is the format you're meant to follow. The base B, like you replace this B with maybe 5. Maybe you want to get base 5 digits minimum and maximum. So it's be 0 to, let's replace this B with 5. So that'll be 0 to 5 minus 1. That's 0 to 4. That means base 5 digits can have 0, can have 0, 1, 2, 3, 4, but nothing higher than that. Okay. Now, the addition rules in base 2. So the first one is 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 1 0 base 2. 10, you don't say 10, but 1 0 base 2. And you're like, that's odd. 1 plus 1 is 2. But since according to these digits or these rules, base 2 cannot have 2. So what are we going to do? Very simple. 1 plus 1 is equal to 2. But 2 is not allowed in base 2. Like I said, it's not one of the rules. Sorry, let me. And since 2 is not allowed in base 2, we divide it by 2. So basically, this 1 plus 1 equals base 2. We divide it by our base 2 here. Alright, so you won't be confused. This 1 plus 1 equals 2 is different from this base 2 over here. That's what I'm trying to say. So let me clean that. So basically, the 1 plus 1 equals 2 here will be divided by the base 2. So 2 divided by 2 is equal to 1 remainder 0. So we write 0, which is our 0 here, and then carry 1. So if it's something like this, 1, 1 plus, and we're asked to solve. So it's going to be 1 plus 1. Remember, it's going to be 2, right? Then we divide it by 2, and that will give you 1 remainder 0. Sorry, forgive me. 1 remainder 0. And what were the instructions we were given? Write 0, carry 1. Okay. So we write the 0 down, and then we carry the 1 to the other side. So we're just going to put it here. Now, because this 1 is up here and there's nothing below it, nothing to add to it, we're just going to bring it down. I'm just going to bring it down. So that's why it now becomes, sorry, that's why it now becomes 1 0 base 2. Chicken now. Okay, so let's clean all of this off. All right. Now let's go up to the next rule. 1 plus 1 plus 1 is equals to 1 1 base 2. How? Let's look at it. 1 1 1. Now final answer is going to be in base 2. So 1 plus 1 is 2. 2 plus 1 is 3. Now we have 3 divided by 2 because 3 cannot exist as a base 2 digits. Base 2 only has 0 and 1. So that's why we have to divide it by 2 to make it actually fit. So 3 divided by 2 is going to be 1 remainder 1. And what were the instructions? You write down the remainder, like here we wrote down the remainder and carried the actual number. So we're going to have so we're going to write down our remainder, which is this. We're going to write it down 1. And then we're going to carry this one up here. And just like before, we don't have anything beneath it like this. Nothing to add. So we're just going to drag this down here and then boom. 1 1 base 2. Now that's the same method we use for the last rule too, which is 1 plus 1 plus 1 equals 102. Okay. So you can see the main focus, the one we write down, is the remainder. Okay. And this question here, let me actually give like an example. Whenever you have something like 1 1 1 1 and you're asked to solve, like when we add all this, we're going to have 4. 4 divided by 2 is going to be 2 remainder 0. You write down the 0, right? Perfect. Let me just put this in. And then they said we should carry the what? The 2. So that will mean the 2 will be up here. Now we can't write, unlike the previous ones where we just drag it down, we can't do that. Why? Because it's not following the rules of base 2 having only 1s and 0s. So what are we going to do? Very simple. We're just going to do like we've always done. Divide it again. So that will mean that this 2 over here, we're going to divide it by 2. And when we do that, we're going to have what? 1 remainder 0. So let me complete this again. This is 0. So we're going to write down the 0 again and then carry the 1. So put it here. And then very simply drag it because now it's matching the rules. Just put it down here. We're going to have 1 0 0 base 2. So that's how it works. I hope you can see the magic in this. Very beautiful, isn't it? The world of bases is quite interesting. So now we've only been treating the rules, the regulations. We've not actually gotten into much action. So now we need to actually do that. So let's move. Now we're going to use this example here. Okay. So 1 plus 0 is what? 1. Okay. 1 plus 1 is what? 1 plus 1 is what? 2. Now we divide that 2 by 2 and we're going to have 1 remainder 0. So write down the 0 and carry the 1. That's where this one is coming from. So 1 plus 1 is 2. So we follow the same process again. We write down the 0, carry the 1. 1 plus 1 is what? 2. So we're basically just following the same process for all of these numbers. 1 plus 1 is what? 2 divided by 2. So we write down 0, carry 1 again. 1 plus 1 is what? 2 divided by 2, 1 remainder 0. So we write that down again and carry the 1. So that's big. And since this one doesn't have anything to add to it again, we just drag it down like we've been doing. So let me just briefly go over this again. 1 plus 0, 1. 1 plus 1, 2. Divided by 2, 1, remainder 0. We write down the remainder and carry the 1. Now, 1 plus 0 plus 1, 2. 2 divided by 2, 1, remainder 0. So we write down the 0 again and carry the 1 again. And then we go through the same process. 1 plus 0 plus 1, 2 divided by 2, 1, remainder 0. Write down the remainder, carry the 1. Now we have to do it again here. So that's 1 plus 1, 2. 2 divided by 2, 1, remainder 0. So we write down the 0 and carry the 1. But now it's finally going to end. I mean, the repetitive front and back, or you know what I mean. Now we don't have any other digits to it, so we just bring down the 1 here, like that. So addition of bases is fairly straightforward. Just understand the rules, and mind you, this is only one method of solving it. I'll show you another very popular method of solving addition methods very soon. But just in case, you can solve these exercises in your free time to show that you properly understand what we've treated so far. Okay. So now we're going to move on to the second method of, sorry. We're going to move on to the second method of adding bases. And that method is very simple. It follows these 3 steps. You first convert to base 10, then you add, and then you convert back again. So you add 101 base 2 plus 11, that's plus 1 base 2. You don't say 11, you say 1 base 2. Now we follow those simple instructions we did before. That'll be 1 times 2 to the power of 2, 1 times the base. The base is 2. One times base 2 to the power of 2. So 1 times base 2 to the power of 2. The next one, 0 times base 2 to the power of 1. Next one, 1 times base 2 to the power of 0. So that's where all of this actually came from. Then our final answer is going to be 5 base 10. Okay, so now that we have 5 base 10, we're also going to do the same and convert the other base 2 number to base 10 as well. So we follow the same process, and finally our final answer is going to be 3 base 10 and 5 base 10. So now the second step is to add the 2 numbers together. That's 3 base 10 and 5 base 10. And that's very simply going to give you 8 base 10. Then afterwards, we then convert it again back to base 2. Remember the steps. Step 1, convert to base 10. Step 2, add the 2 like base 10 numbers or values we got after converting them. And then finally, the third step is to convert it back to base 2. So 8 base 10 back to base 2. So 2 in 8, 4, remainder 0. 2 in 4, 2, remainder 0. 2 in 2, 1, remainder 0. And 2 in 1, 0, remainder 1. So our final answer gave us 1000 base 2. Very simple, very straightforward. I feel like this method is a lot easier to use than this method I showed you here. But it's still a good idea to know both methods. Just use whatever works for you. Now, our second topic is subtraction of bases, right? And we're going to look at the first method, because the same way we have 2 methods for addition is the same way we have 2 methods for subtraction, and those 2 methods are basically the same. You know, the first method of addition of bases, we first memorize the rules, then we divide it if it's too big or it exceeds the rule, max and minimum. That was the first method. And the second method just involved us converting to base 10, then adding, then converting back to the original base. So that's how the second base works. subtraction also works. The two methods of subtraction, that's how it works as well. So let's get into it. So we're going to have 1 0 0 0 1 1 base 2. Subtract 1 1 1 0 base 2. So so we need to know those rules again. We already know this one, so we have 0 minus 0, 0, 1 minus 0, 1, 1 minus 1, 0. But what if we try 0 minus 1? 0 minus 1 is not going to be possible. I mean, how can you subtract something from nothing? You obviously can't do that. So, you know how in elementary school, when you have something like, let me see, 2, 1, 4, and you're asked to subtract maybe 5 from it. You know, back in those days, we would panic that, oh, 5 is bigger than 4. What are we going to do? And your teacher will simply tell you, okay, take 1 from here. So this will give a 0. And then take this one to the other side. So you put it next to it. And that will give you 14 minus 5, right? It's exactly the same way in base 2, but with a twist. So in base 2, if you have something like maybe 1 0 minus 1, sorry, minus 1, right? Let me, okay. So if we have something like this, 0 minus 1 can't work out. So we would ideally borrow the same way we did here. So if we borrow, we should have 0 here, right? Perfect. Now, you're probably thinking, yeah, put 1 here. No, that's not how it works. For So in this case, in this question we were this elementary question we normally used to solve as kids, right? We put the 1 here. So that's basically like saying the one we borrowed is not actually 1, right? It's 10 plus 4. Sorry. Plus 4 to give you what? 14. Because if not, you would have just basically been putting the 1 up here and then say 1 plus 4 will give you 5, or 5 minus 5 will give you 0. But no, we had 14 minus 5. Okay? I hope that is kind of clear to you all. Let me just clean this up in case. Okay. So what you would do is after borrowing from here and leaving 0, we're not going to borrow 10, right? We're going to borrow in base 2. So we're going to borrow 2. So our 1 is our 2. And just like in elementary school, our 1 was 10, not just 2. So that's how it works. Okay? So let's actually solve this together. So now we have 2 here. And very simply, 2 minus 1 is what? 1. So our final answer would be 1. Because this is 0, so it can't do anything. That's how it works. Let's get back into it. So that's how it works. Now let's look at this question. 1 minus 0, 1. 1 minus 1, 0. 0 minus 1. It's not possible, right? Okay. So we move to this number. Can we borrow from 0? No. So what do? We move to the next number. Can we borrow from 1? Yes. So after you borrow from 1, you're left with what? 0. Now, you take what you borrowed and put it here as what? 2. Because that's the base we were given. So you put it here as what? 2. Now, remember, we're coming here. We're actually coming here. Because this is the point. We wanted to borrow from here, but realized we couldn't borrow from here. So we jumped it and went here. So now when we borrow from here, we need to take whatever we borrowed from here to here and then to here. I hope that's clear. Now, So now we have 2 here, right? But remember we're still going here. So we have to borrow from this 2 again to give you 1 and bring it here. And what are we being what do we have here? Instead of 10 like we would in normal elementary maths, we put 2. We borrowed 1 from here doesn't mean we're going to put 1 here. No, we're working in terms of bases. So we have to put the base number here instead of 1. I hope that's clear. So we're now going to have 2 minus 1, 1, 1 minus 1, 0, 0 minus 0, 0. So our final answer was just 101 base 2. And that's all about subtraction. Then we have the second method of subtraction, which is fairly simple. You convert both of them. We convert this to base 10, and then we convert this to base 10 as well. Then we subtract them as they are both in base 10, and then convert them back to base 2. So I'm honestly not interested in uh, looking at that, because if you already understand the addition, you should easily understand the subtraction. So let's actually go to multiplication of bases. Ooh, we've come a long way. I hope we are understanding everything that's been treated so far. If you have any questions, you can drop it in the comment section. If you wish to subscribe, please subscribe. If you're enjoying the video, please like it. If you're not, I really hope you're not hating it. Don't leave a dislike remark, but if that's what you feel, you can also do so. Okay, so the third topic is multiplication of bases. So I'll teach the first method, and it's actually just like normal, you multiplication. One, we were told to multiply 101 base 2 times 11 base 2. 101 base 2 times 11 base 2. So very simply, we're going to have 1 times 1, 1, 1 times 0, 0, 1 times 1, 1. So it's basically like your normal multiplication. So let me just use this to explain. So 1 times 1, 1, 1 times 0, 0, 1 times 1, 1. Then we go again, 1 times 1, 1, 1 times 0, 0, 1 times 1, 1. So now we add them, in case you didn't notice the add button here. So we add them together. So 1, 1 plus nothing, 1. 0 plus 1, 1. 1 plus 0, 1, 1. So you bring everything down, our final answer is 1, 1, 1, 1 base 2. Now, I know I said I'm not going to teach the second method. I actually am not going to teach the second method, but this is basically what you have to follow. Convert them to base 10, multiply it, and then convert back to base 2. The reason why it was so fast for this question is because we didn't have to like follow those, we didn't have any difficult rule to follow. So that's why it was so fast. So I really hope you enjoyed today's class. Please subscribe, leave a like, leave a comment, share this video to your friends if you think it would be helpful to them, and a very big thank you to all of you for watching this video to the end. Thank you.